For example, today also we'll be talking about, to some extent, about how to formulate mathematical models. The best way is to talk about some situation, some example. We will try to take over those things. Specific examples is always good. Even if you talk about, I will also suggest you, not only not only I will suggest, I will ask you to suggest some problems. For example, sir, I want to model this kind of system. What should be the starting point? All those questions you are always free to ask. So please be prepared for, from your side, any queries is there you want to model. Please, of course, you keep the modeling part with respect to biological systems, like lab experiments, what you normally do. Do not assume something abstract and try to model. So that will be not really relevant for you to understand. We will also take some real example in future, not right now, once you learn how to model. So still now we are just exploring the observation and we are trying to model. Okay, and these aspects we will continue even today, that how we are going to make modeling of system. I mean to say, writing the equations is very important aspects. When I'm taking this class, let me start my presentation somehow, then we will discuss more. How do we discuss? Okay. I will also recommend you to go through the textbook. Okay, even if I am not strictly following the textbook, I don't feel so. It is not really required, but I will definitely suggest you to go through how people are making formulation of models, right? What type of mass balance model? You see, you are always telling steady state balance. So rate of mass inflow equal to mass outflow, right? Then dynamic balance. So how much is coming in is how much is going out and how much is produced, maybe, or changes will be there, anything. So like that, we already talked about component balance, anything we are talking about, maybe biomass, maybe substrate, whatever you are going to talk. We can also put this balance we have already used, right? Mass of substrate accumulated in the system is how much is coming in, how much is going out, and how much is consumed by reaction, right? You remember in our last class we talked about substrate consumption and biomass production, and we have used these component balance equations, right? Elemental balance is also same thing, but not rightly required now. If you encounter such kind of problem, we can also make a balance on your elements also, carbon, nitrogen. You can make a balance on that. Normally you do already in stoichiometric balance, you normally do. And so how we are making a balance, you know, right? We are making a imaginary boundary and we will try to make any balancing equation. Balancing equation is very fundamental. They're the starting point before you are going to do any kind of biological process modeling. So you need to know this. Just to go through simple theory only, nothing more than that. Gas transfer, you see, so gas phase to liquid phase mass transfer is happening. So KLA, I told you, na, K into A into concentration gradient is the driving force. Similarly, product formation rate, all those things we discussed. You please try to go and see these things, mass balance, total mass balance. So 1.3, I think you will take care on that. Then basic bioreactor concept, when we discussed, to some extent we already discussed bioreactor models, batch, continuous, or fed batch. Of course, fed batch separately we have not discussed. I will discuss them definitely. But continuous start tank reactor, CSTR component, we have already discussed in our earlier last class. This is about the reactor components. And then we'll have some biological kinetics, you see, structure, unstructured model, what are the different kinetic equation. We'll be talking on them more detail before we actually focus on how to formulate the models. Okay, so that part we will discuss a little bit more later on. So bioreactor modeling is there, mass transfer modeling, gas liquid mass transfer, that we have already learning, right? So there is not really a new things we are talking, because gas phase mass transfer you already know. And then once you learn the approach, then we'll have further things on simulation and modeling, when I will deviate from largely from the textbook. Now, okay, too much we discussed. Now coming into some problem case. How to make a model is the very important things to know. Let me tell you one case. Okay, I am asking you to make a model where one microorganism is growing in a batch study. I'm talking. It is growing in a batch shake flask, and it is producing. It is taking glucose. Okay, it is taking glucose as substrate and producing some acetic acid. So I'm asking you, first thing in your modeling exercise is to understand the process, write the basic reactions, and then write the mathematical equation. So now I'm asking you to make I'm asking you the exercise to do the modeling exercise in a batch reactor. Okay, batch reactor open means cotton plugged, for example, or aeration is happening, aeration allowed. Batch reactor which is consuming glucose as the principal substrate, and it is producing acetic acid. And I am also assuming that acid can be some inhibitory effect is there. Depending on pH, I am assuming acidic environment inhibition is there. For example, or we may not assume that also. So you understand what I am going to make a model. So this is an example case, and I'm asking you to do the same exercise. So for example, you are growing, try to draw the diagram. This is, for example, one shake flask. Of course, some volume is there. No need to worry because batch volume remain no change. And what is happening? I'm telling who are the member. So this is my flask, right? So this is my boundary rather. Of course, not boundary, even cotton plug is also there. So this is my boundary. So now you see, this is my boundary. Beyond this, inside everything is my inside component. And who are member of the model? If I ask you, you are taking glucose, right? You are having some microorganism. They are producing acetic acid, right? Yes or no? Are you understanding what I am talking?
Yes, sir.
So glucose is food, microorganism is there, they are producing acetic acid. So at least you write these three fellow. Glucose is there, biomass is there, acetic acid is there. That's all. Anything more you want to add into the picture? Do you want to add anything into the picture to make a model? Yeah, I want to get some response, right? Not silence.
No, sir.
No. Okay, very good. So Darshan is not interested to do anything because it will make his job more difficult, right? Okay, you may not do anything. If I am not doing anything, then my picture is here. But you should know that acetic acid is something ionizable compound, right? It can actually ionize. So even if you say I do not want to do, that is not really justified, Darshan, here. If it is something, for example, a macromolecular structure which does not ionize, or it is producing from glucose to some other compound, or starch to glucose, you are allowed. because your molecules should not be ionized. But acetic acid case, no, that is not the case. Acetic acid will definitely will try to break up and it will form acetate and hydrogen plus ion. Do you know that? That will happen. Okay, you will say, no, no, acetic acid will not ionize much, sir. I will ignore. Okay, if you ignore, then I have nothing to say on that. If you ignore, ignoring is not a good idea. If you ignore, first of all, then what is the variables you have? I am having glucose, I am having X, and I am having acetic acid. I am not making any ionization. Then what should be my model here? Simple model. Then somebody may come and tell me, sir, they are not considering carbon dioxide exchange, something they are not doing. True, it may happen, na? Some carbon dioxide exchange may also take place, yes or no?
Yes, sir.
From atmosphere. Oxygen transfer may take place, yes. Anyway, oxygen is not going to change the chemistry, but carbon dioxide is definitely going to change. In our last class, I told. And not only that, sometimes I am simply ignoring that even the microorganism also produces carbon dioxide. Yes or no? Yes. Microorganism can also produce carbon dioxide. So you should be very careful when you are actually modeling these things, because some carbon dioxide may come in or go out. Anything can happen, right? Coming in or going out. Some carbon dioxide is produced inside, and then carbonate chemistry. So many complexity can be there. Before I make any model, I'll start the very basic one where nobody told me to model this oxygen and carbon dioxide. So can I expect that you will tell me some mathematical equations for glucose, biomass, and acetate? Ignore carbon dioxide, ignore ionization, ignore oxygen, all those things you ignore. So I am having three things, right? And I told you if I'm having three things, I need three equations. Okay? So first equation for growth, I am telling you everyone, each one and everyone, when you make a growth model, you should write first the growth model, always, because I have to make for growth, I have to talk about substrate, I have to talk about product. Okay, but growth is always, you should try to write in the fast manner. So growth model, what model you will take? Okay, temporarily I am assuming every model I am discussing nowadays, you can assume growth model is a monod model. Okay, so if it is monod model, then dx dt equal to mu into x, yes or no? And mu equal to mu max into s, yes or no? Mu monod, and x is there, so I'll write. So this is for mu, x is already there, I'm writing x. So I got a mathematical equation, dx dt equal to mu max ss ks plus s. So only growth, you understand? This is the change in biomass. So this biomass is actually newly growing biomass. If you consider death, that is your consideration completely, then you can add, what you can add? Minus death rate into x. So if you assume that microorganisms are also dying and growing, so this is new add, this is death. Okay, are you getting my point? Yes or no?
Yes, sir.
All of you please respond these points. Growth rate when I am modeling, is this model at least somehow representing your idea? Okay, this is monod equation, this is the new biomass formed, and this is some biomass died. That's all. Kd is a parameter, Ks is parameter, mu max is a parameter. These are all parameter. I don't know, but maybe someone will know this. I don't know for time being. Kd. If I know, then it is more easy for me. So this is for growth. For substrate, so for example, glucose, I will write the equation, dg/dt, I will write. So what about glucose? You know that glucose consumption is for two purposes. It is consumed for producing biomass, yes or no? So it is used for production of biomass.
Yes, sir.
And okay, and it is also
And
used for
maintenance.
maintenance also. Yes, correct. And it also depends on how much product is formed. So glucose has many channel. So some portion is for growth, active growth. So I'll put yield coefficient and growth. Growth means what part? Actual growth. This part is actual growth. This is actually new cell produced. You try to understand. This is the new cell synthesized. Only for that part,
Yes, sir.
not for the dxdt. If you make dxdt, then this one minus this one is also there. So don't say only total biomass change. It is only for active growth. Active growth means this part. So actually you should remember that is actually mu max s. I will write ks plus s into x. So this is the consumption of glucose. So this yield coefficient is true yield coefficient. True, because I am only talking about active biomass, live biomass. So this is glucose consumption due to new cell growth, and glucose consumption will also take place due to maintenance also. So for example, maintenance into biomass, okay, maintenance into biomass concentration at any moment. And you may say, sir, this is also used for product formation. Okay, so gamma into dpdt. Dpdt means deacetate, deacetic acid dt. You can say, of course, deacetic acid dt I don't know. I will write deacetic acid dt. What does it depends on? It depends on either, you tell me, every time I should not speak. You tell me, product formation kinetics, how I have written? This is a product. Always, it is a product, right? How we are normally
Yes, sir.
writing? So this portion is growth associated. If it is growing, then product will be formed. And next I am also writing beta into x. This part is, if there is no growth, still product is formed. Particularly this part is for antibiotic production or something like that. This is growth associated production. This is for secondary metabolite production. Means for that part, this equation portion is used. So acetic acid production also I can write like this equation. So you see, I have completely written one equation for growth, another equation for glucose, another equation for acetic acid. Yes or no? We have done?
Yes, sir.
Okay. So this is the very simplistic model I can propose. So this part is for your simple understanding of the thing. And it is a very simple model, not at all complex. But it does not mean that we will always avoid complex model, not necessarily. Let me come to the same problem in a more complex manner. More complex manner means you need to understand what is happening. What is happening there? So many things happening. So now if I assume little bit more complex in the reactor, for example, this is my container. Of course, safe plus, something can come in and something can go out also. Okay. So for example, carbon dioxide can only come in and come out. And I am having biomass. I am having glucose. Okay. And I am having acetic acid. I can have acetate ions. I can have hydrogen plus ion. I can have carbonate ion. Now I'm breaking them. I can have bicarbonate ion. So many things can happen, na? Carbonate chemistry. I can have carbon dioxide dissolved. Yes or no? And some carbon dioxide is going out, for example, just for example, exchange. Either in or out, whatever you say, only one line is fine. So you try to understand this picture I am making. Of course, I have missed something. So whole thing in my container, if I visualize in a very detailed way, I will have glucose, I will have acetic acid, I can have acetate, I am having hydrogen, I can have carbonate, bicarbonate, carbon dioxide in water dissolve, and this is atmosphere. Anyway, is this the whole picture, can I say? Yes or no? Anything you expect more or less? Don't be silent,
No,
please.
no, sir.
No,
What
sir.
is what is my assumption? My assumption is that as here is some carbon dioxide will not remain as carbon dioxide. It will definitely have carbonate, bicarbonate, all those things. Similarly, acetic acid will ionize. Yes or no? It will ionize. Now you are in a big problem. Your first equation is not going to change. Don't worry. I have written that dx dt equal to mu max into s into mu max into s into x divided by ks plus s means glucose, actually glucose plus this thing is not changing, don't worry. So your first equation is no problem. Only problem for glucose also you will not face much problem. Glucose is also no issue. Only problem you will going to face is due to these fellows. These fellows is the problem. Now if I ask you very simple question, what is the change, what is the product formation rate? I mean to say, what is the change of acetate ion or acetate total? You see, if I ask you this, there is some acetate, right, and there is some acetic acid also. Can you see at any time, for example, the reaction is going on, you took one screenshot and you see there is some acetic acid also, there is some acetate also. From where they are coming?
Sir, because of dissociation of that particular.
Correct. Because of dissociation. But their total things is actually product, right? If I say
Yes.
the total acetate, total product, that is actually both. This acetic acid was also produced some day back, and whatever now I am having acetate also, that is actually from acetic acid only earlier. So if I am getting 3 mole of acetic acid and 2 mole of acetate, that means till now the microorganism has produced 5 mole of acetic acid. Currently I am having 3 acetic acid and 2 has been broken down. So you try to understand that whenever I am telling that acetic acid plus acetate, that is actually total product. Yes or no? So now if I say total product, I am writing total product by microorganism dt. What equation you have written? I know you will say, sir, alpha into dx dt plus beta into x. So you should not write now acetate like that. I'll write total product. Now you see total product means this plus this. So can I write this one line simply? If I make a derivative of this side, can I write dt dp equal to dAch dt plus d acetate? Simple derivative. You understand? Y equal to x1 plus x2. So can I write dy equal to dx1 plus dx2? Yes or no?
Yes.
So you see, I am just understanding the concept that whatever acetate I am having or acetic acid I am having, both the fellow actually came from microbial synthesis. So rather than I am splitting them, I am defining a new name that, okay, total acetate. So this plus this, microorganism is producing actually both the things. Finally, they are breaking down. That is a different issue. So for microbial perspective, I can write the production rate of total things dt equal to, because why I can write this? because acetate is not coming out. Acetate is acetate only. It is not broken down also. At least acetate is there, na? Acetate is broken down means this is some acetate, this is acetic acid. Both are having same molecule CH3COOH or CH3COO minus something. So essentially, both the things are talking about acetate or acetic acid together. So I will write simply D-acetic acid dt plus D-acetate dt equal to alpha dx dt plus beta x. I will pause a minute so that everyone will respond me. Do you understand this or not?
Yes, sir.
You understand
Yes,
it?
Yes, sir. Yes, sir.
Yes,
Okay.
sir. Understood.
Yes, sir.
Thank you. Thank you for confirming. Now I will put you in little more trouble because there are many things here which is called total carbon. What are the total carbon? So for example, I'm talking about total carbonate, carbon related things, or we'll say normally we say dissolved carbon, DIC. Total carbon is who are the member? Carbonate, bicarbonate, and aqueous carbon dioxide. Yes or no?
Yes, sir. Dissolved carbon.
Okay. So in my system there is 5 member. Okay. Now in this system there is some change is happening or not? If there is any change here, maybe for example carbonate is increasing, bicarbonate is decreasing, or something is happening, overall some change is happening. Who are responsible for overall change? If I ask you, you see this is my imaginary boundary, right? So if for example, just for a fraction of second, you assume I am taking a picture and I am telling just now I am having carbonate 7, bicarbonate 5, and carbon dioxide aqueous 3 mole. So what is the total number? 7 plus 5, 12 plus 3, 15. Okay. If I say after 1 second, my number is like this: 8, 4, 7. How much is total?
19.
1 second before, how much was there?
15.
So some 4 change is happening or not? Overall, 4 change is happening or not? Happening. Total change is 4 is happening, na?
Yes, sir.
Yes,
Yes,
Who
sir.
is making this change? So you have to think who is making the internal change is no problem. For example, 753 earlier and now it becoming 375. I don't bother because they have simply changed themselves. No issue. But if the overall change is happening, that means somebody must be playing something here. That is, some carbon dioxide is actually produced by microorganism.
Yes, sir.
I will not
Yes,
say
sir.
as carbon dioxide. I will say microorganism is also producing some carbon related things, because immediately it's produced, it will be something, either carbonate, bicarbonate, we don't know. So microorganism is also producing some carbon dioxide or carbon related things because of its growth, because of its respiration, or some carbon dioxide may be simply coming out also. Yes or no? Maybe, or coming in, whatever you will say, either come in or come out, whatever you will say, doesn't matter. It may happen. So essentially, you try to understand, if I say change in total carbon DIC dt, who is, of course I know, that means D, because I told you, na, y equal to x1 plus x2, then I can write D total carbon dt means D carbonate dt, that I always write, no issue, plus D bicarbonate dt plus D CO2 dt. I can write. I'm not worried about that. That is very simple one, simply making a derivative. Okay, that is no problem. But I am asking something more problem. I am asking overall change in the system, total carbon, who are major player, actual player, 2 player. Overall change in the system, there is 2 player. One player is microorganism which is producing something in the water, releasing, or something is coming in or going out from atmosphere. So can I say that DIC-DT is actually production of carbon related things by microorganism, or input from, they are actually changer, yes or no?
Gas exchange. Yes, sir.
They are actual changer. So now I will write this DIC-DT one more time. DIC-DT overall change. Who are the player? Two player. One player is microbial growth. So can I say that as microorganism is growing, carbon dioxide production is also proportional? More growth means more carbon dioxide, something like that. Can I say like that? So if I can say like that, I will say, okay, some constant, for example, some gamma, something constant of dx-dt. So carbon dioxide production rate due to microbial growth is somehow proportional. Or even if you say, no, sir, I don't want to do like that, you can say about glucose consumption rate also. More glucose consumed is more produced carbon. You can say, but I am assuming with growth rate. So something is there. So can I say that carbon dioxide production because of microbial respiration is proportional to its growing rate? Proportionality constant I am putting is gamma. So this is first part. Second part, input of carbon dioxide, that we already know. Input of carbon dioxide is what? Rate of carbon dioxide increase in the aqueous phase. Who are the player? Atmospheric carbon dioxide, I told you, na, that is depending on KLa, whatever equilibrium carbon dioxide concentration, so C star, and whatever currently carbon dioxide, CO2 aqueous. Do you know that? C star is what? C star is maximum possible saturated concentration of carbon dioxide possible, allowed. So this is known, constant. It is depending on Henry's law. I told you last class. I can go in more detail also if you want. But for time being, you understand. And CO2 aqueous. C star is known, constant. KLa is parameter. Gamma is parameter. So you see, I have written one equation. So now can I, instead of this DIC-DT, because DIC is not any actual, there is any compound known as DIC? No. It is just a nomenclature. So I have to remove that, right? In my equation, I cannot use DIC. So you see, now I am removing DIC-DT this side and DIC-DT this side. So I will write dicarbonate dt, dibicarbonate dt, this carbon dioxide dt equal to gamma into this part. Do you understand now?
Yes, sir. We are actually equating the ones we assume to the uh, main component, that is nothing but the carbon.
Carbon related things. Yes.
By the microbe and the fused gas.
Yes. So this is actually net input due to microbial growth, and this is the input due to carbon dioxide exchange. So they are coming, and what they will do? They will only change either carbonate or bicarbonate or carbon dioxide. So simply writing this two line, I took little more time so that you appreciate that there is a total carbon is actually changing. I cannot do it only for carbonate, bicarbonate or carbon dioxide. Then I will be mistake. So overall change of the whole carbon I can do. So you see, I got one equation for these members also. So one equation I can write like this. So you see, now I'll just in a closing statement I will make very soon, not right now. I will ask you now that how many equations I already done?
One, sir.
4, sir.
Yeah. As overall, yes.
No, I will just highlight. Anything I am writing not in this context, my variable how many? I will change a color so that you will appreciate this more easily. I will highlight my variable. X is my variable. Glucose is my variable. Acetic acid is my variable. Acetate is also one variable. Hydrogen is one variable. Hydroxyl is also one variable. Carbonate is one variable. Bicarbonate is one variable. Aqueous carbon dioxide is one variable. So how many? 9. Total 1, 2, 3. I need to have 9 equations. Please keep in mind. I need to have 9 equations. Till now, how many I have written? This is one equation I have happily written, dx dt. 1. Then you see d-acetate dt plus d-acetic acid dt equal to alpha dx dt. That is the acetate production. 2 I completed. Yes or no? Then another equation I completed here. You see.
3 actually. Yes.
Actually, till now I only completed 3. So there is long way to go, I believe. Of course, I can another very easy equation I can write glucose consumption dg dt. That is very simple. Gamma into dx. I told you na last slide also same thing, same story. This is nothing new. This glucose I have used na, that I can use directly, no issue. That I can use. You got my point? Glucose
Yes,
is not
sir.
going to change. So glucose is also there. So till now I have completed only 4. But you know, for 9 things I need 9 equations. Only 4 is there. We are not happy. I need to have another 5. What are the other 5 equations will come? Very easy. Now I'll take you to the other 5 equation I will write. First equation I am writing, you see, and you should actually speak along with me, then only you will finally do. Equal to constant, na? I told you what are
Yes, sir.
this one, the activity coefficient for water for hydrogen and hydroxyl ion. Okay, so ion product for water is 10 to the minus 14. So one equation is done. Of course, I will not write like this. I will say dH dt hydroxyl constant, like derivative simply, plus hydrogen constant DOH dt equal to 0. Just derivative. You see, A B derivative means A constant, B derivative, B constant, A derivative, derivative. So this is one other equation. So how many equation is now completed? How many equations now completed? 1, 2, 3, 4, and this one is 5. Fifth one is over. I need another 4. Okay, we can do very easily. Now I am telling now another equation is also there. You are not. Now I will only use the equilibrium relationship. You see, acetic acid. This fellow is ionized. Do you think there is no equilibrium? Yes. So can I say that acetate hydrogen by acetic acid is a constant? You'll know it from literature. Some value is there. This is always equilibrium constant. So if I make it like this, just linearize K acetic acid, for example. So if I make a derivative, then I can make a derivative of both sides. So I'll write D acetate hydrogen constant D acetate dt plus acetate constant DH dt K constant D acetic acid. Can I write like this? Please respond. Acetic acid ionization is also one equilibrium. So this is a equilibrium relation. I can just make a derivative form. That's all, if you want. But at least this is the equation. Or this one is equation. Any one. Either you say this or this, whatever you want. Just derivative form. This is possible or not?
Yes, sir.
6 is over. I need another 3. Now it is very high time you should respond. Another 2 equation I can very easily write. H2CO3 forming HCO3 minus. This is also one equilibrium will come. I am not writing again. Last class we have written, you remember? This equilibrium constant is, for example, K1. You can use that. Because you see, carbonic acid means, carbonic acid I should not write. I will write like that, aqueous carbon dioxide. We are already using, now these are the 9 members, you see, aqueous carbon dioxide. So I can write like this. So this equation is correct. I can use that or not?
Yes, sir.
Any another one you people will
Yes,
tell
sir.
me? Another one I can use. Hey, you should be always outspoken in this class.
So carbonate.
Yes, yes, yes.
Bicarbonate.
This is also having K2. 8 equation I got. We are nearly close. Then what hell? Another remaining equation is there. Who is that? Who is the last one? Which will satisfy our whole purpose? Any one of you can tell me?
Product.
Whose product? Hey, please tell. Otherwise, that is the learning part. You will train your brain to speak correct things.
Charge balance.
You remember we talked so many things. Who are the charging member? You see, I'm having acetate, I'm having hydroxyl, I'm having carbonate, I'm having bicarbonate. Only 4 fellow are there, nothing more. So can I say who are the positive charge? Who are the negative charge?
H plus and OH minus,
Uh,
CO3 minus, CO3 minus.
hmm. Okay, here also I will again ask you, what about carbonate?
So 1/2.
Very good,
Yeah, 1/2.
very good, done. Okay, you got my point? So 9 equation is ready. Of course, they are in these equations, these kind of equation, when I am writing them in a linear fashion or equilibrium fashion like this. Not normally they are not derivative, right? We are making derivative. That is different. So these equations are known as algebraic equation. But for growth, this dx dt, I have to write dx dt only. Mu into g into x, k plus s. These equations are known as differential equation, right? You know that. So what is happening? My whole system, I have to write. What you learned in this class is that when there is any bioprocess, first thing is that to what depth you should analyze. So Darshan initially told he will only analyze with this thing. He will not go for this ionization, all those things, blah blah. Okay, then he was very happy. Only 3 things he was using. He was done. But then we are assuming no, this is not the real picture. Real picture, so many things is happening, because with this system I cannot talk anything on pH. pH required that if I am talking anything on pH means I need hydrogen plus ion. That means ionization I have to do completely. So then okay, I understood this whole block should be there. Acetic acid is the product means I have to go like this block. I have to make a imaginary boundary, and then the concept will come into flow. And then I am writing for each of them. I am trying to write some equation, some formation. Total change of inorganic carbon I have to understand. Total change of acetate kind of things I have to understand. And we are done. We are so 9 variable is there, and somehow we have successfully written 9 equation. Means your job, initial job, of course, very initial job is over. You have successfully modeled the system, not solved. Solving is a different issue. It is a mathematical issue that I will discuss in our next class, because it is already 12:45. Okay, any questions from your side?
Sir, so basically for any particular equation, we should always consider this charge balance at the end. Is it?
No, not necessarily. When I was only modeling for if there is any charge, if
That
I'm
is, if
discussing
there are
anything
any
in charge,
ions.
there is ionization things are there, then charge balance will definitely count, because
Yes,
otherwise you will always have a shortage of one equation.
Yes, sir. Fine.
So charge balance will be used for that case.
Yes, sir.
Okay.